What's up everyone, Karthik here, founder and CEO of Agam Robotics. I know I haven't updated for quite a long time. There's a lot of things going on in terms of development. I'm not sure if you had checked the YouTube shorts. I'll put a full video of that here. There was a slight confusion when I was asked by a few members whether the flight controller really worked. Unfortunately, no, that's not our flight controller. As I had mentioned in my previous video, I wanted to test with the off-the-shelf parts. Because of few reasons. One being the parts were from the FPV drone setup. I wanted to know whether it's all working or not, like motors, ESCs, the frame, everything. Usually one would use individual ESCs on these type of autonomous drones. The FPV style uses 4-in-1 ESCs. There's no clear process of how to wire on the autonomous drones, like the Pixoc. The third reason being these drones typically use flight controller, flight communication system or radio communication system, like a S-bus protocol based, and the one I use is like a crossfire communication system. So getting the crossfire to work with the autonomous flight system or the Pixoc was too complicated because no one uses that in the autopilot ecosystem, right? They use FR Sky or Fly Sky and so on. But getting to work with Crossfire and ELRS is there's no documented process, or there is it's not really clear information of how to set it up. So I had to go through all that process, make changes in the firmware, build it, and then upload it to the flight controller to make sure it's working. Nevertheless, it all worked flawlessly. The 4-in-1 ESCs, trying to communicate with the flight controller, or the radio control system with TBS Crossfire communicating with the drone. So that was a really daunting task to get the whole thing working. So the first video of that which I tested was a couple of weeks. So that's the video you're seeing right now. I had to do a tethered test because I had to make sure there's no flyaways. Sometimes, usually, even though I did a lot of bench testing on these motors and the frame and the whole setup, there are chances that the drone could go with full throttle and then fly away or hit something or damage properties and so on. So I had to test it out with the tethered, and the untethered test was once I knew I had all the controls and made sure it's all good, I unhooked the rope and then I let the drone go freely. As you can see here, the drone flies a lot, swaying around because there's not much sensor getting the feedback, or the drone is not getting the feedback from the sensors. So those sensors would be something like GPS, flow sensor, or distance sensor. So now that I have added all those sensors in the setup, so there is a GPS and there's a flow sensor and distance sensor mounted on the bottom. So this would make the drone much more stable. So getting this to work also took a lot of time. I had to make changes in the build and set it up with all the parameters, made sure all the sensors are detecting the values correctly, did a full bench test, and then I took it out in the field. So this is the video. As you can see, the drone is completely locked in its position as compared to the previous part of the video. You can see that it's not swaying around, and as it is closer to the ground, the optical flow sensor and the distance sensor are actually locking in its position and not making the drone move. And if I take it slightly higher, the flow sensor and distance sensor won't be effective. So the drone would lean more towards the GPS signal. So the GPS is locked, and initially I did not make sure the GPS was locked. Even though I got a green signal on the GPS, it wasn't clear whether it was locked. And after a few trial and error, I was able to get it working. All right. As I mentioned, I wanted to test with the off-the-shelf parts. So none of this in this drone is the parts I had designed or tested or manufactured. So everything is off-the-shelf parts. I bought the parts, put it together, There were like a few things I had to make changes because, as I said, like the Crossfire or like the 4-in-1 ESCs are not something people would use on these type of autonomous drones. They would usually go with like individual ESCs, as I mentioned before. So this is something really important because once we replace the flight controller with ours, we will know like these components are all working together. So now that we are like very clear that this whole setup is working, that's when we can like move on with like swapping parts of the ones we design and manufacture. Unfortunately, the flight controller firmware is still going on. Like it might take like a few more weeks, is what I'm like guessing. It's more about like the bootloader and like the firmware development which is happening. And to get like the bootloader working with like our flight controller, there is a lot of changes to be done with respect to the NXP Semiconductors chip, like the microcontroller. So that's something is in the works. I think I might probably have to ship the board to the NXP team in Netherlands for them to like test it out and see like everything is fine with the design of the board itself, with the manufacturing process and everything so on. Before shipping that, I wanted to like also mention that we had to change an IMU component, like I had mentioned in the previous video. So we did receive the components. So I need to like find someone who can do this repair because I don't have a soldering rework station. So the component needs to be swapped, and you need to like put this into this and get it shipped. Okay. So once that component is swapped out, I'd be also receiving like the IMU board and the Flexcable, which we spoke about in the last video. So we'll be able to like test that into the drone and like see if all the sensors are working. So probably I'm guessing like the IMU board, like the IMU sensor board would be the first component that would be swapped into this drone. The board would go into the stack over here inside the flight controller. So it'll have like the off-the-shelf flight controller with like our sensor board and test it out. And I'm also guessing like the flow sensor should also be here. And the component has been shipped, but the assembly process is going to take some time, and then like it's going to get shipped. So that should happen either this week or early next week. So we'll also have like the flow sensor that would be swapped out and tested. So this is basically the update that has gone for the entire month. So if you have like any questions, or if you want me to talk about any specific things, or emphasize more on any of the specific components what we have discussed here, I would love to do that. Please let me know down in the comments, and if you have like any suggestions or feedback, I would be happy to like listen to that. Thanks for watching. Until then, see you in the next video. Bye.